Let's say I want to make the two columns. I want to aggregate the sepal length and the sepal width, because I saw that those two are in one properties, and let me make it as a summation. So I want to sum the sepal length and sepal width, and let me create a new variable name, which is total sepal. In this case, there will be a new column. So the new column is total sepal, and the total sepal is a value. So we can get this 10 because it is the summation of the 6.7 plus 3.2. So we have the sepal length plus sepal width. Yeah, we can have another kind of operator. For example, we have sum, we have product. Product means multiply. Or we can find the minimum. Or we can find the maximum, the mean between the two variables, variance or median. Okay, that's about the dimensionality reduction. Okay, so the first thing in the data reduction, first we learn about dimensionality reduction. And this is about how to reduce the columns or reduce the attributes based on some techniques. Now we enter the second section. How if we want to reduce the numericity or the data? We want to reduce the data in terms of the volume. We want to reduce the data volume, means we want to reduce the rows. If we have a lot of rows, 1 million rows, 2 million rows, we want to reduce it. How we can reduce this one? Yeah, there will be some methods. The first, we can say it is the parametric method. So parametric, it is from the word parameter. So you have the parameter to determine how you can reduce the data. In this example, I can say one of the method to reduce the data with parametric method is regression. Assume that the data fits to some model and estimate model parameters, store only the parameters, and discard the data, except possible outliers. So if it is outliers, of course, you will just eliminate it. Okay? But if some data are in range, you can select with this equation. Linear models. The linear models, we can have many variants. For example, the log linear models. We can obtain value at a point in m-dimensional space as the product on appropriate marginal subspace. Yeah, we call this is parametric because we have the model. But there will be some other methods which is non-parametric. We do not assume the models. So there will be no models, and we just use any methods. For example, histogram. Okay, you know histogram. and then we can use clustering, and we can use sampling. Okay, so we will check those methods. The first is the parametric data reduction. The data reduction with parametric method. There are some methods. Here I explain about regression. The first is linear regression. The linear regression means we have the variable x and we have the variable y. Okay. And there will be coefficients. These coefficients, which is w and p, it specifies the line and are to be estimated by using the data at hand. So the data is x and the data is y, and w and p we need to calculate it. So we call later it is the linear regression model, and the model is having the weight in a particular value and p in a particular value. We will use least square criterion for estimating the y from the x. The other way to do the regression, we have multiple regression. In the linear regression, usually we call it simple linear regression. When we say it is simple linear regression, means we have one x, we have one variable, and we have one target value or one target column. So the multiple linear regression, from the word multiple, means we will have multiple variables, and usually we will have one target. So the multiple variables, it can be x1, x2, x3, x4, and so on until xn, and we will have one target, which is y. So that's why we have the formula y equals to beta 0, it is the coefficient, plus beta 1 multiplied by x1. x1 is the variable, plus beta 2 multiplied by x2. x2 is the variable. Many non-linear functions can be transformed into the above. So if it is the linear regression, usually we can create a line. So just one line, we call it linear. If it is non-linear, then the function will be different. We can have something like quadratic. So the non-linear, we can have the function like y will be equals to b0 plus b1 x1 plus b2 x2 power of 2. Okay. So it is non-linear because the x should be in quadrant or quadratic. Or maybe you have another b3 with the quadratic, or you have another variable x4 with cubic. Cubic means the exponent 3. So if there are some exponent values in the variable, because this is not linear function. We can use the log linear models. We need to approximate discrete multidimensional probability distribution. So when we want to find this probability distribution based on the word log linear model, usually we use log function. So the log function is y equals to b0. In one option is b1 multiplied by the log of x1. So we make the log function. We make the log function of the variable x1. And then if we have x2, then we will also make the log function of the variable x2. We can estimate the probability of each point or tuple in a multi-dimensional space for a set of discretized attributes. So in this log linear models, we can also determine the y, not the real value of y, but we can make it as the logarithmic of y. So the y has a function. It is useful for the dimensionality reduction and data smoothing. So if we can use the log function, yeah, we can reduce the data as well with this model. So I do not want to discuss more about the log linear model, but let's see only this regression analysis. The regression analysis is a collective name for techniques for the modeling and analysis of numerical data. Okay. Here we have the x, it is numerical, and we have y, it is also numerical. And we want to know, is there any dependency between the x and y? We learn about the correlations. And the correlation is one way to check the dependency between those two variables. We call dependent variable or response variable or measurement. So if we have the y equals to beta 0 plus beta 1 x1, then we can say that y is the dependent variable because it is dependent on the independent variables. So the x1 is independent variables. It can be one or more. So there can be one variable, there can be two variables, there can be three variables, and so on. And we can say it is the explanatory variables, or sometimes we call as predictors. The parameters are estimated so as to give a best fit of the data. So let's see if we have this data dot this dot is data. So we can estimate. How can we get this line? We can get this line because we want to check the this error, and also other errors. So if the errors are the least, what is the meaning by least? It is the minimum. Okay. If the error is the minimum, then we will select this line. So maybe we can have option like this line, or we can have line like this one. But if other line is not minimum on the errors, we will not select it. We will select only the least errors, or we call this is least square method. So it can be used for the prediction, including forecasting of time series, inference, hypothesis testing, and modeling of causal relationship. Histogram. I think you know about the histograms. We learned about the equal width and equal frequency. Equal width and equal frequency. The idea is we want to divide the data into buckets. We want to divide the data into buckets. This is the first bucket. This is the second bucket. Maybe this is the third bucket, and so on. Or maybe this is the bucket. Yeah, this is the bucket, one bucket. This is the very small bucket here. And we can see this is the frequency. So the data will be divided into buckets and store. It can be stored in the average, or we can store the sum for each of the bucket. So you already learned about the equal width, where the bucket are equals in the range, and the equal frequency, where the buckets have the equal depth. Clustering. We call clustering because we want to make clusters. We want to make clusters. So the cluster means group. We want to make group. So if we have one big data set, how we can make the group? So we will calculate the similarity. And we want to check if we can save the data, store the cluster representation. Maybe we will check what is the center value. Maybe we need to check the diameter. It is very effective if the data is clustered, but not if the data is smear. Do you know what does it mean by smear? Smear is another word of dirty. Let's say this face. If you learn about face recognition, you can see the face clearly. Where is the eyes? Where is the nose? Where is the mouth? Where is the ear? But if the face are dirty, it will make some confusion. So this is also the same with the clustering. When you have the clustering, if the data is dirty or smeared, then it will give you not a good cluster. So it will not be effective. So there are many choices of clustering definition and clustering algorithms. We will study in separate section. Sampling. Sampling means we want to obtain a small sample S to represent the whole data set. So we have the N. N is the population. And we have the S. S is the sampling, or we can just get some of the subject. For example, I want to ask about the Korean people who live in other countries. So if I ask to all the Korean people in the country, there will be very tedious job. It will be so complex. So we can just get some sample. Who will be the representative of the audience to be the respondent? It will allow the mining algorithm to run in complexity that is potentially sublinear to the size of data. So the key principle is we need to choose a representative subset of the data. Okay, so the keyword is representative. So we want to find the best data that can represent the whole population. In a sampling, we can use like the simple random sampling. Just randomly select the subjects. But it may have very poor performance in the presence of skew. Some other sampling methods, we call it the adaptive sampling methods. For example, stratify sampling. So let's see some types of samplings. Simple random sampling. In a simple random sampling, there is an equal probability of selecting any particular item. So we just use the probability. What is the probability to select this one? Okay, I will select 1 and then go to the next. I will select this one and then I go to the next. I will select this one. I will select this one. I will select this one, and then you have some kind of probability to randomly select the data. There's another way to do the sampling. We call it sampling without replacement. It means that once the object is selected, it is removed from the population. Sampling with replacement. A selected object is not removed from the population. So let's say if I have population, I have data 1, data 2, data 3, and then if I want to do the sampling, so I select this data. Okay, after I select this data can be duplicated and we can again choose this data for the sampling. So this data can be selected again for several times because we do not remove from the population. It means the data or the object can be pre-selected. But the sampling without replacement, because it is removed from the population, so there will be no option for the pre-selection. Stratify sampling. Stratify sampling means we want to partition the data and draw samples from each partition. Partition means we want to make group, we want to make clusters, and we will draw samples from each partition. Let's say I make this partition, and then I make this partition. I make this partition, and then I make this partition. So from each of the partition, I would like to do the sample. I want to do the sampling. I want to do the sampling. I want to do the sampling. So because this is the simplified sampling, and this will be more proportion. Correct proportion. It will more represent the population. So this figure is try to explain about the sampling with and without replacement. if it is simple random sample without replacement. Then once you select one object, and then you select another object, and you select another object, so the object will not be placed. So the objects will be selected here, but there will be no of that object in this population. But if you use the simple random sample with replacement, so the other picture is the with replacement. This one is simple random sample with replacement. Once you select this object still in the population. So let's say if you do the sampling again, there might be a possibility to select the same object. So the same object can be selected, or the same object can be reselected. And this one is from other. Okay. We can do sampling with the cluster or stratified sampling. Let's suppose we have this raw data. And then I can have the data with three colors: blue, black, and white. Now I can make the cluster sample. The cluster sample means, let's say I want to just select two clusters. Let's say this one is the cluster sample. So I make cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. So among those 5 groups, I want to select only 2. And yeah, I will just select only this and this sample, because this is cluster sample. Or the stratified sample, yeah, like what I explained before. If I can distinguish based on the groups, the group of the light blue, the light blue groups and the blue groups. So the light blue groups, I will select 1. From this light blue groups, I will select 1. From this blue group, I will select 2. So yeah, we can say this is the stratified sample. We can also reduce the number of data using the data cube aggregation. The aggregated data for an individual entity of interest, we can make it as a cube. You know cube? Cube is a small box. So we call this is cube. And let's suppose we have sales data cube. And we have 3 different attributes: time, location, item. So time, this is based on a quarter: Q1, Q2, Q3, Q4. Cities, let's say this is Chicago, New York, Toronto, Vancouver. And item, let's say this is home entertainment, computer, phone, security. Maybe the security is about the product, the security product. Okay. Now I would like to know 605. What does it mean? 605. It means that it is the sales on Q1 quarter 1 at Vancouver, and the product is home entertainment. What about 825? 825 is the sales on Q1 and it is in the city of Vancouver and the product is computer. Okay. So let's say I want to just analyze the computer. Then we can just get only the computer. And you know this kind of cube. It can be represented in the multiple levels of aggregation in data cubes. We can further reduce the size of the data to deal with. For example, maybe in the first time I have the data for every month: January, February, March, April, May, June, July, August, September, October, November, December. But I think that, okay, it is too much. It is too many. If we analyze all of those, can we reduce it or can we aggregate it? Okay, I can aggregate into quarters. So for January, February, and March, I can aggregate it into Q1. April, May, June, it can be aggregated into Q2. So if I have this data on January, February, March for the security, 150, 100, and 150, then I can just accumulate. The total sales in the Q1 is 400. Okay. Okay, let's see from the audience. Now let me just use the iris data, and I have the select row. Because we are going to reduce the number of data, we are going to reduce the volume. So we can use select rows. And in this select rows, there can be option. Let me remove all. How you can select the rows? Okay, I can add a condition. Let's say I want to choose only the iris. From the column iris, I would like to choose only the iris setosa. Okay. If you check on the data table, then okay, let's see. If you know this data contains of 150 instances. So we have 150 instances, no missing value, and I want to reduce the analysis. So I want to analyze only the setosa also. And you can choose it, the select rows, the iris equals to iris setosa. And we have 50 instances, and those are the iris setosa. Or let's say I want to give another condition. I want to add another condition. Maybe the sepal length. I want to check what is the option here. Here we have equals, is not, is below, is at most, greater than. Okay. Let's suppose I want to check the sepal length, which is greater than 5. So you can check if it is greater than 5. Okay, this is the data of iris setosa, and the sepal length is higher than 5. And we have 22 data. So we can use this based on the condition that we already select. We can make linear regression. You can make linear regression. Before we make the linear regression, we need to select the column. Okay. Why do we need to select the column? So if you go to the linear regression directly, you have linear regression. It will be errors. And there will be an error message. Numeric class variables expected. What does it mean? When I explain to you, the linear regressions should have variables x and y, and those variables should be numeric. Okay. So we need to define this one by select column. Okay, now it is still errors. So if you open the select column, we call the features is the x. So this is the independent variable or predictors. So we call this is the predictors. This is the independent variable, or we call this is the explanatory variable. And the target is the response, or this is the y. We need to determine what is the y, because we have to select the numerical attributes. So let me just remove all. And okay, let's say, can I predict the sepal width? And can I predict the sepal length based on the sepal width? So if I know the data, if I know the sepal width, then I know what is the sepal. Is there any function to determine the sepal? Now you can see that there is no error. And in this linear regression, we have some option actually, but I do not want to discuss it now. We can have no regularization. We can have rich regression, lasso, elastic, but let's just use the no regularization. If you make a data table, so there will be a coefficient. We call it, this is the model. It means I can say that the y, what is the y? Y is the sepal length. I can know the sepal length. The sepal length is a function of the intercept, which is 6,48122, and then multiply by the weight of sepal width, which is minus 0.20887. So it is y equals to the 6.48122 multiplied by minus 0.20887 x1. What is the y? The y is the sepal length. And then what is the x1? It is the sepal width. Then if I know value of the sample width, I can predict or I can know what is the value of the sample. So based on this model, we can select what is the proper data. Or if you want to reduce the data, we can select the most closest to the line. So the option to make this linear regression is you can make the scatter plot. In the scatter plot, let's say you want to check the sample width and the sample length. So this is the sample width and this is the sample length. Okay. And if you want to show the regression line, okay, so this is the regression. This is the regression, and we can predict something based on this line. Now let's suppose I know this data, and then okay, I do not want to choose the upper side. Okay, I do not want to choose this one. I do not want to choose this one. So I want to choose the data in this range for further analysis. So in orange, you can block. You can click and then you can make this selection. So after the data has been selected, you can go to the data table and then check what are those data that we just selected. So this is the data that I just select from the reference one. We can also do with the distribution. We can do the distribution here. I want to select the, let's say, I want to select only the low petal length. So you can press shift, 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 shift. So I would like to choose those distribution based on this histogram. Okay. And then if you open the select data table, then you will see that the selected data is based on the condition, which is the petal length higher than or equal to 1 and lower than equal to 2. And you can also do with the sampling, data sampler. With the data sampler, there are some options like fixed proportion of the data, fixed sample size, or cross validation, or bootstrap, and so on. But let's just use this fixed proportion data or fixed sample size. And there are also another option whether you want to replicable deterministic sampling or you can use stratified sample. So let me just uncheck this one. So let's suppose I want to select 50% data. I want to select the 50% data and then there will be no check here. If you want to see the data, let's see the distribution of the data. Okay, this is the original data. Right? The original data have the equal distribution. Iris setosa, we have 50 or 33.3%. Iris versicolor, we have also 50 data, which is 33.33%. And we have the iris virginica, 50 data and 33.33%. Now, when I do the sampling, 50%. So I want to get 75 data. How the sampling works? It chose the iris setosa 26 or 34.67, iris versicolor 28 or 37.3, and the iris virginica is 28%. So the proportion or the distribution is different from the original data. Now, if I just stratify, sample, and then if I again sampling the data, now you can see that the proportion of this data now becomes equal. Because with the stratified sample, we want to select the same proportion for every of the class. So you can check this one. The iris setosa, we have 25 data. This is 33%. This data, iris versicolor, we have 25 data, which is 33.3%. And the iris virginica is also 25 with 33.33%. So that's the meaning by the stratified sample. And you can also use this fixed sample size, let's say 75. Okay. You can select with the sample with replacement or sample without replacement. So if it is without replacement, of course, the object has been removed. If it is with replacement, then the object will be in the population again. So if you check, and I uncheck this one, let's see. Okay, this is the data after we do the random sampling. Oh, let me choose. So you can see the proportion will be different because I didn't use the stratify. And then if I use the sample with replacement, okay, so I check this sample with replacement. Then now the distribution is more diverse. So you can check later with replacement, without replacement, what is the difference and so on.